Understanding policy gradient proof line by line, line number 1. We want to understand the proof on page 325 of Reinforcement Learning Second Edition book. I will number the original proof from the RL book line by line so we can pick apart each line. This is line number 1. Let's get going. So first let's read the beginning of the proof. So what the authors are saying here is that with just elementary calculus and rearranging of terms, they can prove the policy gradient theorem from the first principles. Also, to keep the notation simple, they omit the parameter theta from all the policies here. So pi here just means pi of theta implicitly. And the same for all the gradients. These gradients are with respect to the parameter theta. So here the line we're trying to prove says that the gradient of the state value function v pi of s can be written as the gradient of the action value function q pi of s of a. So in other words, we can express the value function as action value function. Okay, so let's isolate line number 1 by itself and move it up to the top so we can always see our goal. So the first thing we want to note is that there is a relationship between the value function, state value function, and action value function, and that's depicted by this backup diagram here. And so the value of s here is dependent upon which action we actually pick and the value of each one of those actions. So the probability of picking each action is just our policy. So our policy says that if we're in this state, we're going to pick this action with this probability, etc., etc. And the qs of a is the action value function that tells us once we pick this action, what is the value of that action. So if you look at this and you squint slightly, you will see that this is just the expected value of the action value function q pi over all actions under this policy pi. And so this is exactly this term E right here. So expected value under policy pi of q pi of SA over all the actions A. So this means that we take each probability Q and we weigh it by this pi and then we sum them. So this is just the definition for the expected value, but you can also look at it as a weighted sum over all the action values by our policy. So once we have this, we can take the derivatives of both sides here, and what we arrive at here on the left is the gradient of v pi of s, which is exactly what we needed, and on the right we have the gradient of this sum, which is what we needed as well, and this gives us line number 1 exactly. This was also the solution to exercise 3.18 in the book, which is why you see it mentioned here in the proof. So if you chose to do your homework since last time, you have already arrived at this point. All right, that was short and sweet. See you next time. Bye.